What's up? What's up? What's up? It's your boy, the network. And today's topic is subsection 3.2E Echo DHCP Relay and Server. This is a subsection under the section 3.2 Identify IPv6 Addressing and Subnetting. This is for the CCNP ROUTE exam code 300-101 version 2.0. Let's take a look at the exam blueprint to see where we came from and where we are headed. All right, so this is the exam blueprint implementing Cisco IP routing. Again, this is the CCNP ROUTE exam code 300-101. We just wrapped up, autoconfig SLAAC, which is basically a way of auto-generating an IP address using EUI64 and receiving the prefix from a router advertisement, from a default gateway. Today we are going to be doing section 3.2E DHCP Relay and Server. After that, we're going to do 3.2F DHCP protocol operation. So we're just going to kind of go deeper into it as far as DHCP goes, and the messages that go back and forth. We're going to talk about the difference between DHCP for IPv4 and IPv6. So remember, this section right here is what we're doing today: DHCP Relay and Server. We did that in layer 3 technologies, 3.1c, but that was for IPv4. Today we're going to be doing it for IPv6. Now, the main difference between the two, I would say, is there's a couple more messages that that go back and forth between the client and the server. Sometimes the server is not even required in IPv6 because a host or a client can auto-generate its own IP address. It's like, I don't need you. I got myself. I'm going to create my own address and then communicate from that way. Let's head over to take a look at the official definition. We kind of know the official definition, so I was going to talk about... also, let's talk about DHCP relay as well. So, hosts on the network needs IP addresses to communicate on the network, right? How does it attain its IP address? From the DHCP server. And like I just said, IPv6 hosts don't need a DHCP server. It can generate its own IP address. That's the main difference. Now, DHCP relay is a service that is on a router or a layer 3 switch, and that takes the messages. It basically acts like a third party in case a DHCP server is not in your local network. If there's a DHCP server in a remote network, you would go through the relay. It would take the messages from you or the client and then pass the request messages on over to the DHCP server. And it just acts like a middleman between the host and the client, or the server and the client, rather. Okay, so these are the official definitions for both DHCP version 6 server and DHCP version 6 relay agent. DHCP enables DHCP servers to pass configuration parameters such as IPv6 network addresses and IPv6 nodes to IPv6 nodes. It offers the capability of automatic allocation of reusable network addresses and additional configuration flexibility. There's the RFC. I'll put a link in the description below. This is a stateful counterpart to IPv6 stateless address auto configuration, which is what we talked about in the last video, which is SLAAC is the acronym, and that's what it stands for. It can be used separately or concurrently and with the latter to obtain configuration parameters. So basically, you can generate your own address using SLAAC and EUI64. I also have a video on that. Just go to the CCNP playlist. You'll see that CCNP ROUTE playlist. And that's how it generates its own address. But when you do that, you're not going to have other parameters such as leasing information or DNS. You would need a DHCP server to obtain that information. And the relay agent, that's the RFC. I'll put a link in the description below. In short, it just acts like a middleman between a client and a DHCP server. And it passes those messages along. Remember we talked about with DORA? Well, in IPv6, there's no DORA. There is other messages. I believe it's solicit, reply, response, and something else. It's SORR is how I remember it. SOAR. But there's other messages along with SOAR, but the main important ones that we really need to know are SORR. We'll go over that in a little bit. We'll also go over DHCP server configuration and relay agent using Boson. That's right, we're not using Packet Tracer today. Remember, Packet Tracer is more of a CCNA level tool or a learning tool. It is great because of the simulation and stuff like that. But again, that's a CCNA level tool. It's limited with the commands it offers. When we get into the CCNP level, there's other commands and other features that are not available on Packet Tracer, which is pretty much why we had to graduate to GNS3 and Boson when you're studying at the CCNP level. So let's talk about the difference between stateful and stateless. Essentially, we talked about stateless in the SLAAC video. So as you can see here, it says the server does not retain any information about the clients. These are used with SLAAC. Note that the default gateway information is learned from the router using NDP in both scenarios. So remember, we talked about the router advertisement and router solicitation, right? That's how hosts receive information about routers in the network and stuff. It also obtains the router, the network prefix. So in short, the difference between the two, stateless does not remember any of that stuff. Just remember the word less. So DHCP server does not retain information about its clients. You may not want to do this when you have a network that has multiple hosts or a large network. You would need to kind of manage your hosts and your addressing pool. That's where stateful DHCP server would come in. The host learns the prefix and host address from the server, and then the server is going to remember all the information about its clients on the network. So when you're managing a whole, a network with several clients, this is kind of the route you want to take, a stateful DHCP server rather than a stateless, because it's like, again, stateless is where the host generates its own IP address using EOI64 and SLAAC, and that's where the word SLAAC got stateless from, because it's a stateless DHCP. It's kind of like it doesn't really need the DHCP server. It only really needs the DHCP server when it needs leasing information, DNS information. As you can see here, right here, it says stateful, I need an IPv6 address from someone who is keeping track of who has what address. That's stateful. Just remember, full is like managed. And also the server is going to remember the information from the clients and everybody on the network. And that's where he says, hey, I can do that. Stateless is where he comes up with his own address. Again, I sound like a broken record. And no one's going to keep track of what address I have. And that's where the DHCP server is like, okay, I guess I don't be needed. So stateless, he doesn't really need me right now. Okay, and this is more of a breakdown of stateful DHCP server. I also have a breakdown for the stateless, but we're not going to go over too much of that because that's what we covered in the SLAAC video. In stateful DHCP, the address assignment is centrally managed, and clients must obtain configuration information such as address auto configuration, neighbor discovery that is not available with the protocols. They can be implemented in two ways: rapid commit. That's where it uses just two messages, solicit and reply. That's what we were talking about with when I said SOAR. Rapid commit is where you're just sending a solicit message and a reply message. Normal commit, where it uses 4 messages. So this is similar to the DORA that we were talking about with IPv4. So in normal commit, it uses 4 messages. S for solicit, A for advertise, R for request, and R for reply. So this is more SAR, I guess is what it is. SARR. I don't know any other acronyms or any other way to remember it, but SARR are the messages that IPv6 or DHCP version 6 rather uses to communicate between the client and the DHCP server. By default, normal commit is used, and in order to use rapid commit, it has to be enabled on both the client and the server so that it uses two-way message. So you have to on your host enable it to use rapid commit as well as the server. So we'll go over the configuration in Boson in just a little bit. Again, this is stateless address auto configuration. I'm not going to get too much into that because we did a whole video on SLAAC. If you haven't seen that, then you are slacking. Get it? Anyway, this is another video. You want to get more into that, watch that video. Or you can freeze frame it and read this right here. I'm not going to read all these PowerPoints, y'all. All right. And this is the DHCP relay agent, similar to what we did with IPv4. You got a middleman or a third party or intermediary, whatever you want to call it, in the middle that's passing those, in this case, the SAR messages, SARR. So he just stands in the middle between the client on the right-hand side and the server on the left-hand side and just passes those messages along. And the reason why he needs to be there is because this client right here is not in the same network as the server. So we have to have a relay agent in the middle. Simple. We've talked about this as well in IPv4. I'm not going to get, I'll show you the breakdown in Boson. This is how you configure it. So you go to the interface, and remember in IPv4, it's IP. You go to the interface and type in IP helper address and then the address of the DHCP server. In this case, it's IPv6 DHCP relay destination. Yes, I know it's a little bit more convoluted, but that's just how they did it with IPv6. And then you put the IPv6 address of the DHCP server. And just basic definition, it creates a relay forward message. So remember, again, IPv4 has the DORA, and IPv6 it has SARR, and then the relay forward is just another message that's tacked on when you need to go through a relay agent, the relay forward message. Not all these. Shout out to Professor Graziani again for these PowerPoints. And he's got all these animations. I guess I didn't really time it or look at this. So there's link scope. The output interface must be specified for this type of address. And this is a basic configuration example. I'm not going to go explain everything here. We'll do that in Boson as well. So this is the IP DHCP pool. When you create the pool, remember in IP version 4, you just type in, I believe it's IP DHCP pool and then the name of the pool. Then you put in address command instead of the network command, which is version 4. You also have to put in the lifetime. This is basically the lease time. You can do lifetime, and then you can put how many seconds or how many. By default, I believe it's 24 hours for IPv4. Not too sure if it is for IPv6. I'll put it in the notes below. IP DHCP server interface binds the pool to the interface. And then there's also the M flag that we need to talk about. I'll go more into that in the next video. The M flag is the managed flag. That's when you have a central DHCP server that is going to be managing the addresses in the pool and remembering how many clients and their addresses. There's also the O flag, which is, we'll go over that, I believe, in the next slide. Here's another configuration example. You can pause it, freeze frame it. All right, we're back. I'm not going to go break that down for y'all. This is similar to IPv4. The only difference is, let's see here, the manage config flag. When you want to manually set that to the M flag to be turned on, and then the leasing information, which you would put after the IP the address prefix, and everything else is similar to IPv4. Again, two flags, the M flag and the O flag. O flag is other configuration flag when it needs to obtain other information along with its prefix and its IP address. The other information will be leasing information and DNS. Managed configuration flag is when you need the DHCP the server to give you everything, the IP address, the prefix, leasing information, DNS, all of that. And the domain name, all of that. That's when you need a DHCP server to do all of that, manage. So this is basically telling you whether you want to do stateful versus stateless. You can break down this stuff in Wireshark. I'll probably give you an example of that, or maybe in the next video. But when you look in Wireshark, you'll see one of these bits will be turned on. One of these flags will be turned on with either a 0 or a 1. Well, it's turned on with a 1 and it's off with a 0. By default, they're both set to 0, and we'll talk about what that is. That's yeah, right here. Both flags are set to 0, option 1. And that's basically saying use me, RA. So that's router advertisement message for all your addressing information. No additional information is available via DHCPv6. Here's the other configuration flag, set to 1. That's the second option. And that's stateless, just like what I was saying. And then managed is full. So remember, managed full, other, stateless. Here's another client configuration. I'm not going to go get the rest of this is all client configuration information examples. We'll just go over all of that in Boson. So let's go ahead and fire that up. Right here, we have the same topology that we used with the SLAAC example. We have the core router, or layer 3 switch rather, and then router 3 that we're going to be doing configuration information. And I believe we're going to do a relay agent on distribution switch number 1. So this will be a relay agent. We have our hosts right here. Don't worry about the access switches. So again, I believe we're going to do the relay agent on this guy, set the pool on this guy or that guy. I can't remember, but let's go over that right now. This is the command summary. Don't get too hung up on these guys right here. These are just how you obtain information, renew and releasing information on the hosts, the clients, the computers. They're not exactly, they kind of try to make it similar to Windows command prompt with IP config /all, etc. But they're just used in this program to kind of get the host information for the hosts, or IP addressing information for the hosts rather. So let's move on. This will be our prefix, or these are our IP addresses for the core and the distribution switch. We have 2 VLANs on the distribution switch. First thing we're going to do is configure stateful on the DHCP server. We're going to do, let's go first step. I'm not going to read all that, y'all. Configure PC1 to obtain IPv6 address and extra non-address information using a DHCP server. So the way we do that is we go to PC1, which is this guy right here. Obtain its information by using a DHCP server. I believe you do that with renew 6, but he won't be able to because, let's see, ipconfig /renew 6. Again, this is not these are not commands that you really need to know. These are just used on these hosts to obtain that information. So we could do ipconfig /all. You can see he got a linked local address, but we don't have any kind of IPv6 addressing. We don't even have IPv4 addressing information. We need to obtain that. We got no DHCP server information. So we need that for the host, basically. On PC1, verify the IPv6 is enabled. How do we do that? I believe it is, okay. See, this is not something I really need to know, but for these hosts, we need to know to do that, to configure it. ipconfig /ipDHCP. Again, these are just arbitrary commands. IP space DHCP. Now it's basically enabled on the host. So ipconfig /all to see what we've got obtained so far. Still nothing. But that's how you enable it on a host on Boson Netsim. Alright, so are any IPv6 addresses configured on PC's network interface? If so, what type? Yes, there is, and it's a linked local address. Remember, linked local FE80. That's what we just looked at right here. So that's his linked local. This was generated using UI64. Remember, we put the FFFE in the middle and obtained the rest of the information through its MAC address. Notice this is the MAC address. Chopped it up in half, put an FFFE in the middle, and generated a linked local. But that's not routable on the internet. We still need an IPv6 address. On core, create a DHCP pool named DHCPv6 100. So we're going to go to the core router, or layer 3 switch if you want to be technical. Enable, configure, terminal, IPv6 DHCP pool, and the name of it was this. I believe is case sensitive, so make sure you stick with that. I know in version 4 it is cap sensitive. DHCPv6 100. DHCPv6 100. All right, so that's the name of the pool. We need to configure the pool to use a DNS server of this and a domain name of a.example.com. So we need a DNS server. So DNS server, and then put that address and a domain name, which is a.example.com. a.example.com. On the core, configure DHCP pool to provide stateless IPv6 addresses from that prefix. Right? So we need to set that as the prefix, basically. What's the command for that? This is a new one that's not in IPv4, because we're basically saying, here's the prefix, y'all. Here's the prefix, y'all. 2001. Let's get rid of the IPv6 and just type in the address. That's what it was. That's what it was. You don't put in IPv6. What was wrong with this one? Oh no. Anyways, that's the prefix we're going to be advertising now. On core. Not on core. On the router core or layer 3 switch core. We need to configure fast Ethernet 01 interface to operate as a DHCP server that distributes address from this pool. So basically, you're going to go to, let's save what we've done so far. Do copy, run, start, and exit, and go to interface FA 0/1, and we need to have this interface operate as a DHCP server that distributes address from that pool. So basically, IP DHCP, and then no, that's wrong. How do we do that? I forgot, y'all. Okay, so it's this guy right here. No pool name. It's this guy right here. So that's different. We don't do this on IPv4, but this is what we got to do on IPv6. So it's IPv6 DHCP pool, and then you put pool, and then the name of the pool, which is DHCPv6 100. Now that interface is going to be handing out addresses from that pool. Next step. So on call, verify the configuration of the pool. Have any stateful clients obtain information from the DHCP version 6 pool. How do we do that? Obviously, it's going to be show command. Exit out of that. Exit out of that. We could have done Control Z. Show IPv6 DHCP pool. And now we can see that's the configuration of the pool. Active clients, none. So no, nobody has an IP address binded to them yet. On core, verify the information of the pool. We've done that. Has any statement? No. Verify the server is running on the FA01 interface. Is the server using the correct pool? How do we do that? We have to go to the interface FA0/1, and it's IPv6 DHCP server, I believe it is. Server, see? That's what we forgot. We forgot the keyword server right there. This you have to enable DHCP server on an interface and say that's where you're going to be handing out your IP addresses. You don't have to do this in IPv4. This is something you got to do in IPv6. So you got to go to the interface IPv6 DHCP server and then the pool name. So in this case, DHCPv6 100, Now the interface we was trying to do, or the show command we was trying to run, was show IPv6 DHCP interface FA0/1, and there we go. Now we see that the interface is in server mode using that pool. I don't know what preference value is. I'll look it up and put it in the comments below. Hide from client ignored, rapid commit disabled. Remember, rapid commit is whether we want to use just the two messages, solicit and reply. And normal commit, which is what it's set to right now, is when we're going to use all the SARR messages, right? So moving right along. So we did our show command that we needed. That was the command I was looking for, y'all, right there. All right, so we verified the DHCP server is running on the interface. Is the server using the correct pool? Yes, it is. On PC1, release and renew the IP configuration information. So let's go to PC1. And we're going to run that same command before. IP config release 6. Again, these are fake commands. I don't even think you can do a release 6. I don't know, but I know you can do IP config /release for IPv4 on a Windows computer. But you know, this is just something for this software here. Now we're going to do IP config /renew 6. And take a look at what we've got. IP config /all. Do we have an IPv6 address? No, we don't. We have a linked local address. We still have our MAC address as usual. Why is that? Take a look at this topology and tell me why. This is PC1. We set the DHCP server to be this guy right here, the core. This is supposed to be a layer 3 switch. Why did he not get an IP address? I'll give you all a clue. Relay. Y'all see that? This guy right here. So the main reason why is because we need a relay agent. We're not in the same network as the core. So one of these guys is going to be our relay agent. We're going to set distribution switch number 1. This is actually a layer 3 switch. They just used the wrong icon for this guy. So yeah, we're gonna set this guy to be a relay agent. Let's go ahead and do that. On PC1, you can see right there, that's the question. Has PC1 configured to use an IPv6 address with that prefix? Why or why not? Or why not? If not, why not? So yeah, that was the reason why we need a relay agent. So we're gonna configure a DHCPv6 relay agent. We're gonna do that on DS1, just like I said. So that way it forwards client message information from the client to the server and back on the core's FA01. So on distribution switch 1, configure VLAN 1 interface to operate as the relay agent. So we're going to use a VLAN, layer 3 VLAN interface. And then on distribution 1, configure VLAN 1 interface to operate as a relay agent and forwards client information to the server at this address. So we're going to distribution switch 1. Let's go to that guy. So in distribution switch 1, enable configure terminal interface VLAN 100, and then you say we want to make him a relay agent. Remember, in IPv4 it's IP helper address and then the address of the server. In this case, it's IPv6 DHCP relay destination. I know it's a long one. Then you put the address of the DHCP server, which is this guy right here. Enter. Enter. And now we've created a relay agent. Verify that the relay agent has been configured on VLAN 100's interface. How do we do that? Exit show IPv6 DHCP interface VLAN 100, and there we go. VLAN 100 is in relay mode. I didn't even really remember that. I just kind of used kind of like not really common sense, but just like a process of elimination. to try to figure out what that show command was. I didn't even remember that. But VLAN 100 is in relay mode. Relay destination is that address right there. That's the DHCP server. What's the next thing we got to do? On PC1, release and renew. Let's go to PC1. Do the same thing we did before. Release, renew. And right now he says address assigned. And we got to assign an address. We can verify that with ipconfig/all. That is a real command. I know that for a fact. And as you can see, we got our link local address as well as our IP address, IPv6 address. Right there it just says, I don't know, this is why I didn't like this software sometimes. Look at that. It says IP address, IP address. Obviously, by looking at it, you can tell which one's IPv4, which one's IPv6, but still, they could at least put IPv6 address right there. All right, so moving right along, we got an IPv6 address for PC1. On the core, verify that the PC1 has binded with the DHCPv6 pool. Go to the, this is our DHCP pool right here. And we're going to verify that by doing show IPv6 DHCP pool, I believe it is. And there you go. That's the pool, DNS server, one active client. But that's the pool. That just tells us how many clients we have active. How do we tell who's binded to it? Obviously, you just change pool to binding. Show IPv6 DHCP binding. I believe it is. Yeah, and there we go. Unassigned username. We got the client link local address. VRF is default, and this is his address right there. Lifetime, preferred lifetime. If y'all don't know what that is, that's I believe 24 hours right there. So that's preferred lifetime. Valid lifetime 172,800. I don't really know the difference. I'm gonna look that up and put it in the notes below. Expires January 2nd, 2019. If you don't know, I did this video on New Year's Eve, so this is just before New Year's Day. And what else can we do? What else do we need to do, rather? Verify that PC1 has obtained stateful addressing information, including IPv6 address, DNS server information, blah, 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 which I believe we did already. Where's the DNS info? Right here. Link local, global. What else they want to know? That's the DNS server. That's the DNS. That's the DNS. That's the domain name, rather. What else? On-core, not Encore, but on-core router. Verify that the DHCP version 6 pool is advertising that prefix and this DNS server and that, which we did already with the pool, I believe it was. Yeah, show and then pool. So let's go back to the core. And yeah, we did that. See? Cool. So, if you like this video, please comment, like, subscribe to the network.